All right, this is lesson 8.3, rotations. This is our third rigid transformation that we're learning about, our last one before we get to a non-rigid transformation called dilations. But these rotations are rigid, so they'll keep the same size and shape. Our objective is that you'll be able to rotate points and shapes and determine the rotation given an image and its pre-image. So here's a picture of a rotation, and typically we rotate in the same direction that we number the quadrants. So you should know where quadrant 1, 2, 3, and 4 are when we have a graph. But if you don't, here's a quick review. We have an x-axis and a y-axis. Quadrant 1, I'm going to use Roman numeral 1 here, is the upper right quadrant in our graph. This is labeled quadrant 1 because it's the nice quadrant. X's and Y's, the x-coordinate and the y-coordinate are both positive in quadrant 1. After that, we go counterclockwise. So quadrant 2 would be the upper left quadrant. In quadrant 2, any point there is going to have a negative x-coordinate, but will still have a positive y-coordinate. Quadrant 3 has two negative coordinates. Both x and y are negative in quadrant 3. And finally, in quadrant 4, any point in quadrant 4 is going to have a positive x-coordinate, but a negative y-coordinate. So just like our quadrants are numbered in a counterclockwise direction, we measure rotations counterclockwise. Just get rid of that. There we go. Counterclockwise. So if you're asked to rotate clockwise, we'll find the equivalent counterclockwise rotation, and I'll show you the shortcuts for that in a little bit. So here's some rules for rotating counterclockwise about the origin. All of these rules, I'm hoping you already have an idea. You may have even written these down already in class when we go over, when we were looking at the rotation file on Desmos. We were rotating different points, and we noticed some patterns about how the x-coordinates of the x-coordinates and the y-coordinates of the pre-image and the image, they look very similar, but sometimes they change sign, or sometimes the x's and y's swap. So here is where we can record those ideas. As you can see, whatever xy pair that we start with, if we rotate 90 degrees counterclockwise around the origin, we're going to swap the coordinates, and the old y-coordinate is going to change sign. So the opposite of the old y-coordinate will be the new x-coordinate, or the old x-coordinate of the pre-image will become the y-coordinate of the image. And then you can see similar rules for rotating 180 degrees counterclockwise or 270 degrees counterclockwise. This last one should come as no surprise. If you rotate 360 degrees, and you've made a complete circle, and you're back where you started. So the coordinates of the pre-image won't change at all, and they'll be the coordinates of the image as well. All right, so here's those equivalent rotations, though, if we want to go clockwise instead of counterclockwise. I'm going to draw a quick picture. Let's say we have some point P, and I'm going to draw a line through P in the origin, and I'm going to also draw a perpendicular line up to that line, also through the origin. Okay, so let's say I wanted to rotate P 90 degrees. Oh, change my color. How about red? If I rotate it 90 degrees, then P prime might be somewhere over here. Hopefully you can see that, well, I could also rotate clockwise, but then I'd have to rotate it more degrees, right? That would be 3 90-degree angles. 1, 2, 3. That's 270 degrees clockwise. And I get to the same spot as if I rotated 90 degrees counterclockwise. So 90 degrees counterclockwise is the same as 270 degrees clockwise. I'm not going to draw a picture for the other ones. The pattern, though, is that these degrees should add up to 360. We're completing that circle. So 180 degrees counterclockwise, well, that's actually going to be the same as 180 degrees clockwise. We'll end up in the same spot. If we want to rotate 270 degrees counterclockwise, that's the same as 90 degrees clockwise, because 270 and 90 add up to 360. If we want to rotate 360 degrees counterclockwise, well, really, it's going to stay in the same spot. That's the same as 360 degrees clockwise, or you could say just 0 degrees clockwise. It's not going to change the coordinates. You could say or 0 degrees. Either way, 360 degrees won't change the coordinates. All right, so don't forget these rules. They're very important. Write them down, use them on a note card. We're going to keep referring back to them. So in example 2, it's saying rotate 180 degrees counterclockwise. And I'm looking at my table. This is the rule I'm going to use. So xy goes to negative x, negative y. So we already know we're rotating 180 degrees. We need to use this rule, this transformation. We're going to apply that rule to points D, E, and F. And then we'll have our image. So coordinate D, negative 2, 5. If I apply this rule, D prime, the coordinate of the image of D, should be the opposite of the x-coordinate. So the opposite of negative 2 is positive 2. And then the opposite of the y-coordinate, the opposite of 5, is negative 5. That's it. We're just changing the sign. So we can do the same thing with point E. E is a coordinate of the pre-image, and it's 0, 4. That means E prime is going to be the opposite of 0. Well, negative 0 is still 0. And the opposite of 4 is negative 4. And then F started at negative 4, negative 3, which means F prime is going to be the opposite of those coordinates, 4, 3. And that's it. We just found the coordinates of the image. Try example 3 on your own. Keep in mind we're not using the same rule. We're going to be rotating 90 degrees clockwise. So find the right rule, rotate it, pause the video if you need to, and when you have the coordinates of your image, unpause it and check your work. Okay, hopefully you use this rule. 90 degrees clockwise is the same as 270 degrees counterclockwise. So that means xy should be going to y negative x. And that should map G, H, and F to G prime, H prime, F prime at negative 7, negative 4, 4, 2, and 0, 1. All right, last one. We'll try one together, and I'll have you do one more on your own. Let's start with black. I'm going to do part A in black. Let's graph trapezoid TRAP, where T is at 0, 4. And I'm just going to write this down here. T is at 0, 4. It's going to go somewhere else in a moment, but I'm going to plot that point. 0, 4 is right here. Oh, shouldn't have done that. Just put a point. There we go. And then R is at the point negative 2, 1. Let's plot that as well. Negative 2, 1. It's right there. And then we have A. Point A is located at negative 5, 1. So negative 5, 1 is right here. And then point P is at negative 5, 4. Negative 5, 4. So there we go. We can go ahead and connect these dots. And this is a trapezoid because it has two parallel sides. TRAP. P. Now next, we are going to rotate the image, rotate the pre-image TRAP 270 degrees. Now remember, we're going to measure this counterclockwise, and we know our rule for that. That means XY is going to go to Y comma negative X. You can look that up on our previous page. Rotating 270 degrees counterclockwise about the origin is that rule. So we're going to use that rule. I'm going to rewrite it over here. Y comma negative X to find T prime. We're going to swap places with X and Y and make the new Y coordinate negative. So that'll be 4 comma negative 0 is still 0. R prime, again, we're going to take the coordinates of R and swap X's and Y's. So that would be 1 comma negative 2, but actually it's the opposite. So that'll be positive 2. Negative 2 is positive 2, right? A prime, switch them and make the new Y coordinate negative. So, or actually not make it negative, but make it the opposite of what it was. So if we switch them, we'll have 1 comma 5. The 5 was negative, it became positive. And then P prime, our last one, again, we'll swap negative 5 and 4. So 4 will be the new X coordinate. And then our new Y coordinate will be the opposite of negative 5, which is positive 5. Let's go ahead and plot those. T prime is at 4 comma 0. R prime is at 1 comma 2. A prime is at 1 comma 5. And P prime is at 4, 5. We can connect our dots again. And we've got T prime, R prime, A prime, and P prime. And sure enough, this looks like it's a rotation 270 degrees. Counterclockwise rotation. All right, pause the video, and I want you to do C and D on your own, and then come back and check your work. All right, so you should have plotted points K, I, T, and E. I plotted them in red here, and I wrote their coordinates down here. And then K prime, I prime, T prime, and E prime, I should write them here too. K prime, I prime, T prime, and E prime are coordinates that we get after using this rule. So when we rotate 90 degrees, again, that's counterclockwise, that means XY is going to be mapped to the point negative Y comma X. And again, this negative Y, it doesn't mean that coordinate has to be negative. It just means the opposite of the old Y coordinate. Okay? So when you plot those points, you can apply it here and then plot these points on the graph, and your image, K prime, I prime, T prime, E prime, should be right down there in quadrant 4. Again, that is a 90-degree counterclockwise rotation. That's it for 8.3. As always, ask a question at the end of the video, and I'll see you all in class.